Hello and welcome to this learning video. In the last learning video, we have started the second case of the Fourier series expansion for the given function, and in that second case we have taken one example. Now continuing the same topic but a different variety of example, we are back with this. Obtain Fourier series for f of x is equal to x into sine x in the interval 0 less than x less than 2 pi. So as usual, we are going to start with let f of x is equal to x sine x, 0 less than x less than 2 pi. And what would be the required Fourier series for this function? F of x is equal to a0 by 2 summation n equal to 1 to infinity n cos nx plus bn sin nx. Okay, where what is this a0? A0 is this 1 by pi 0 to 2 pi f of x dx, an is this and bn is this. The same thing we have discussed in the last learning video. The only thing is the calculation is going to be a complicated and somewhat tedious one. So let us see this a0. So we have to find out a0, an and bn. So first of all, we are going to find out a0. So what is my a0? My a0 is this. So this can be written as integration 1 by pi integration 0 to pi. What is my f of x? X into sine x dx. Simple. Now here only you have to apply the integration by parts. So what is it? This is 1 by pi. Applying integration by parts. First function integration of second. Integration of sine is minus cos minus derivative of first, integration of this 0 to 2 pi, here also 0 to 2 pi, and this completes. So now you can just substitute upper limit minus lower limit. So what is it? In place of x you have to put 2 pi first and then 0. So this is 1 by pi, then it is x which is 2 pi cos 2 n pi. So can take minus sign here outside, you can take minus sign outside, minus, and you can write 2 pi into cos 2 n pi minus of this minus become plus, 0 into anything 0. So upper limit minus lower limit will gives you this minus minus become plus. What will be getting? Sine 2 pi, this is just cos 2 pi, not cos 2 n pi, cos 2 pi minus, sorry, sine 2 pi minus sine 0. Okay, now sine 2 pi is 0, sine 0 is 0, cos 2 pi is 1. So this is minus 2 pi upon pi. So I am getting the value of a0 to be minus 2. Is it? Once you get a0 to be minus 2, I am writing all these values over here. a0 is minus 2. Okay, after finding out a0, let us find out an. What is an? Now let us find out an. So formula for an is 1 by pi integral 0 to 2 pi f of x into cos nx dx. So what is it? An is equal to 1 by pi integration 0 to pi. What is this? F of x? X into sin x into cos nx dx. Okay, so whenever you have a term like this, always write the bigger term first. Sin x is bigger or cos nx is bigger? Cos nx is bigger. So you can write 1 by pi integration 0 to pi x into cos nx into sin x dx. Okay, now multiplied by 2, divide by 2, that is the adjustment. Okay, and what is 2 cos a sin b? Can you apply 2 cos a sin b? Yes, 2 cos a sin b What is it? Those who don't know, I am writing this here using 2 cos A sin B. So the formula for 2 cos A sin B is sin A plus B sin A minus B, because cos is appearing first, so it should be minus. Okay, so this is the formula we are going to apply over here. So what is it? This an is equal to 1 by pi. You can take this 2 outside, so 1 by 2 pi, and applying the formula, so this is integration 0 to 2 pi. Integration 0 to 2 pi x into 2, this is sin A plus B, so this is sin, what is it, n x plus x, so this is sin n plus 1 x minus sin n minus 1 x dx. Simple. Now, separating this, you'll be getting 1 by 2 pi integration 0 to 2 pi x into sine n plus 1x dx minus integration 0 to 2 pi x into sine n minus 1x dx. Okay, now you have to solve this integral. So let me solve this integral first. So okay, so see here now, so my an is equal to, what is it, 1 upon 2 pi, apply integration by parts to this, so this is first function, integration of sine is minus cos n plus 1 x divided by the coefficient of x, that is n plus 1. Okay, now this is integration 0 to 2 pi minus derivative of this is 1, integration of this, so minus integration of cos is sine n plus 1 x upon already n plus 1 and n plus 1, so this is n plus 1 whole square, limits 0 to 2 pi. Okay, then this minus x into integration of sine is again minus cos of n plus 1 into x upon n plus 1. It is n minus 1, sorry, this is n minus 1, limits 0 to 2 pi minus 1 into minus sine n minus 1 x upon n minus 1 whole square, 0 to 2 pi, and this completes. Okay, now one remark I would like to make here is that if I take n is equal to 1, this would be infinity, that is not defined, so I have to specify here n not equal to 1, meaning thereby the value of an is like a2, a3, a4 and so on we are finding. We have to find separately an for n is equal to 1. Okay, so now you can just substitute upper limit minus lower limit, so this would be 1 by 2 pi. What is upper limit minus lower limit? So this is only upper limit will contribute, lower limit will gives you 0 into anything, so I am writing it as minus 2 pi into cos 2 times n plus 1 of pi Okay, so this is cos x is equal to 2 pi, so I am writing cos 2n plus 1 of pi upon n plus 1, then minus lower limit is 0. Okay, so this is just this minus plus upper limit sine 2n plus 1 pi is 0. Okay, and just give me a second. Okay, so sine 2n plus 1 pi is 0 and lower limit is also sine 0 is 0. So this is just about this. Now take limit of this. So from this entire term we have this only. This is upper limit minus lower limit, and this is 0 minus 0. Minus x. This minus become plus. In place of x put 2 pi. So this is 2 pi into cos 2 n minus 1 pi upon n minus 1. Okay, then 0 times is 0. Okay, minus 0. This is the limit to this. Minus plus sine 2n pi minus 1 is 0, sine 0 is 0. So we have only one term of cos n plus 1 and cos n minus 1. So cos 2n plus 1 of pi and cos 2n minus 1 of pi is 1. If you want, I can write it here. Cos 2n plus minus 1 of pi is always 1. Okay, and cos 2n pi is also 1. Okay, so here I am writing it as, so this is 2 pi, you can take common throughout, that 2 pi get cancelled with this and we remain with 1 upon this 2 pi you can take common, so 1 upon 2 pi already there and 2 pi common from this both the term. So what we remain with, this and this, so I am writing the positive term first. So positive term first means 1 upon n minus 1, because cos 2n plus minus 1 of pi is 1, minus 1 upon n plus 1. So this get cancelled with this. So what is my an? This is equal to n plus 1. Take LCM of this. So this is n plus 1 minus n plus 1 upon n minus 1, n plus 1, that's n square minus 1. Okay, so this get cancelled. So we have an to be 2 upon n square minus 1. Don't forget to write n not equal to 1. Simple. So what we have found out? We have found out an is equal to what? 2 upon n square minus 1, and here you have to write n not equal to 1. Just because we are writing n not equal to 1, you have to find out a1 also. So let us find out a1. So let us now find out the a1 first. So I have a1 to be 1 by pi integration 0 to 2 pi f of x, that is x into sin x into cos nx, n is equal to 1. So this is cos x dx. So again multiply and divide by 2. Now these are same, so we can take any of them. So this is 1 by 2 pi, okay, integration 0 to 2 pi x as it is, 2 sin x cos x is sin 2x dx. Apply integration by parts to this. When you apply integration by parts to this, what you will be getting then? Okay, 1 by 2 pi, apply integrating by parts to this. So this is first function, integration of sine is minus cos 2x by 2, 0 to 2 pi, minus derivative of first. Says now integration of this is minus sine 2x by 4, already 2 is there, and again 2. So this is 2 into 2, 0 to 2 pi. Okay, so this is 1 upon 2 pi, and here you can take minus sign outside. So this is 2 pi minus of 2 pi into cos 4 pi, okay, and divided by 2. Lower limit will contribute to 0. So this is upper limit minus lower limit to first, minus upper limit minus lower limit, sin 0 is 0 and cos 0 is 0. So this is sin 4 pi 0, sorry, to x is equal to 2 pi. So this is sin 4 pi minus sin 0. So sin 4 pi and sin 0 is 0. You can directly write 0 also, no need to specify all this thing. So now this 2 get cancel with this 2, this pi get cancel with this pi. Cos 4 pi, what is cos n pi? Cos n pi is minus 1 to the power n. So cos 4 pi minus 1 to the power 4, that is plus 1. So this get cancel and we remain with 1 by 2 with negative sign. That's my A1. So A1 comes out to be minus 1 by 2. Okay, now let us find out the B1. Okay, here itself you can find out Bn, B1. So this is because we have to find out Bn first. Very lengthy problem is there. So after finding out A0, An, we are going to find out Bn. So what is Bn? Bn is equal to 1 by pi integration 0 to 2 pi f of x into sine nx dx. So this is 1 by pi integration 0 to 2 pi. What is f of x? X into sine, now I am x into sine x, okay, into sine nx dx. You can write 1 by pi integration 0 to 2 pi x into sine nx into sine x dx. Adjust 2, divide and multiply by 2. Okay, this is, yeah. So what is 2 sine A sine B? So using 2 sine A into sine B is equal to cos A plus B minus cos A minus B. So this is the formula for it. So you can apply over here 1 by pi integration 0 to 2 pi. Take this to outside and here you can write x into, what is cos? Is that cos? Yeah. So cos n plus 1, right? This let me check. This is sin A plus B minus sin A minus B. Yeah. Sin A plus B. Okay. Cos A plus B. So what is it? Cos A plus B. So which is this? Let me check. What is it? To sin A sin B. Okay. So 2 sin A sin B. The formula for 2 sin A sin B is it is like cos of A plus B minus cos of A minus B minus cos of A plus B. So this is the formula we have. So cos A minus B, so this is cos of n minus 1 x minus cos of n plus 1 x dx. Okay, now you just solve this. So this is 1 upon 2 pi integration 0 to 2 pi x into cos n minus 1 x dx minus integration 0 to 2 pi x into cos n plus 1 x dx. Now just apply integration by parts to here, then you will be getting where it is. Yeah, here you can solve. Now just see here, we have this as my Bn. So what is my Bn then? Bn is equal to 1 by 2 pi. Apply integration by parts to this. So this is first function. Integration of cos is sine n minus 1 upon n minus 1 x 0 to 2 pi. Then this is minus 1 into integration of sine is minus cos. So minus cos n minus 1 x upon n minus 1 0 to 2 pi. Now integration by parts to this. So this is minus what is it? X into sine n plus 1 x upon n plus 1 0 to 2 pi minus 1 into this minus cos n plus 1 x upon n plus 1 limit 0 to 2 pi. This completes here. Now as you can see, the first two problems, sine 2 pi is 0 and sine 0 is 0. So the first bracketed quantity will give you 0 minus 0. So this bracketed quantity will give you 1 by 2 pi. This is 0 minus 0. What about this? Minus minus plus. So this is cos 0 is 1, cos 2 pi is also 1. So this would give you minus minus plus. So this is 1 upon n minus 1 minus, okay, just a minute. This is n minus 1 square. This is n plus 1 square. Okay, it is like this. So this is a 1 upon n minus 1 square common. So this is cos 2n pi minus 1. So this is what is it? Minus minus plus cos 2n plus 1. This is 1 and this is cos 0 1. Okay, likewise here, if you can write here, so this is minus in bracket, again this is 0 minus 0 and this is minus minus plus 1 upon n plus 1 whole square. Cos 2 pi is 0, sorry 1, and cos 0 is 1. So this all comes out to be 0. So Bn is equal to 0. Now before I complete this, you can specify here n not equal to 1, because if n is equal to 1, this would be 0 and this would be not defined. So Bn is equal to 0 I am writing. Now I have to find out Bn. You can write Bn is equal to 0 for n not equal to 1. Now you have to find out B1. Okay, sorry. So let us find out now B1. It's a very lengthy problem, I must say. Bn is 0 and not equal to 1. So let us find out B1 now. B1 is equal to 1 by pi integration 0 to pi f of x, that x sine x into sine x dx. 1 by pi integration 0 to pi x into, what is sine into sine? Sine square x. What is the formula for sine square x? 1 minus cos 2x by 2 dx. Is that the formula? 1 minus cos 2x by 2. Now you can take this outside. So this is 1 by 2 pi integration 0 to 2 pi. What is it? What is it? X minus x cos 2x dx. Now you can apply the integration by parts. So this is 1 by 2 pi. So here it is integration of x is x square by 2 limit 0 to 2 pi minus, apply here integration by parts, x into cos 2x. So this is sine 2x by 2 minus derivative of first is 1, integration of this. So this is minus cos 2x by 4, 0 to 2 pi, 0 to 2 pi. Okay, so this will gives you 1 by 2 pi. This is 4 pi square upon 2 minus, what about this? This is 0 minus 0. This is plus 1 by 4. Cos 2 pi is 1. Cos 0 is 1. So this 0. So we have 4 cancel. So B1 as pi I am getting. Okay, so B1 is pi. Now after getting all these values, you can just substitute the values of all these over here to get the final answer. Okay. So this Fourier series f of x implies the required Fourier series number 2. Just you have to substitute the values. F of x is x into sine x is equal to a0. What is a0? Minus 2. So minus 2 by 2 is minus 1 plus summation n is equal to 2 to, okay, so I will write first a1 cos x, n is equal to 1, and then summation n is equal to 2 to infinity an cos nx plus b1 into sin x plus summation n is equal to 2 to infinity bn sin nx. So x into sin x is equal to minus 1 plus, what is a1? a1 is minus 1 by 2. So this is minus 1 by 2 cos x plus summation n is equal to 2 to infinity. What is an? An is 2 upon n square minus 1 into cos nx plus b1. What is b1? b1 is pi pi into sine x plus this bn is 0. So this is the required Fourier series for the given function. So I know this is a very lengthy problem, but if you are very good at integration, then you can solve this as fast as you can. So I hope the problem that I have taken here is gettable to you. So thank you for watching this learning video and have a good day. Thank you.